Good evening to all. Now we are going to discuss about the steel structures. So what is in the steel structure? Steel structure is the main load carrying material to transfer the load within them and to transfer load to the ground. So example of steel structure is I-beam, T-section, channel section and steel plate. Common steel structure used in nowadays: roof trusses in factories, cinema halls, railways, grain girder, columns, beams, plate girder, bridges, transmission towers, water tanks and chimney. So this slide shows about the framed structure of steel structure and old arch bridge structures. You can show this diagram framed structures. Here channel sections are used. Next one, industrial structure, industrial building structures, truss bridges, loads on structures and code book. What are the types of loads acting on steel structures? Dead load, live load, wind load, snow load and special load and combinations, earthquake load. All the loads we are going to refer about the IS 875 part 1 refer for self-height load. Another IS 875 part 2 live load, IS 875 part 3 wind load, IS 875 part 4 snow load, IS 875 part 5 special load and combinations, IS 1893 earthquake load, steel cable is IS steel cable and IS 800 2000. These are the code books are used for steel structures. This slide shows about the some of the images of steel structure: rolled beams and columns, rolled channels, rectangular hollow sections, circular hollow sections, double angle section, T-section and single angle section. Some terminologies used in bolted connections for steel structures. This diagram shows two rows are used in bolted connection. Here what are the terminologies used? Pitch, gauge, end distance and edge distances. Pitch is nothing but it is a center to center spacing of the bolt in a row measured along the direction of load. Gauge distance is nothing but it is a distance between the two consecutive bolts of adjacent rows and is measured at right angles to the direction of load. Edge distance is the distance between bolt hole from the adjacent edge of the plate. End distance, it is the distance of the nearest bolt hole from the end of the plate. Terminology in bolted connection: staggered distance, it is the center to center distance of staggered bolts measured inclined direction of the member. Now we are going to discuss about the efficiency of the lap joint. Shown this diagram, two plates are connected, the thickness of plate equal to 20 mm, the pitch equal to 60 mm, edge of the edge distance E equal to 30 mm, another one thickness of plate 20 mm and width of plate equal to 180 mm. Here M20 means the bolt of diameter equal to 20 mm, therefore D equal to 20 mm, diameter of bolt hole T0 equal to 20 plus 2. 2 is nothing but spacing between the bolt, therefore you can write T0 equal to 22 mm. Ultimate strength F of UB equal to 400 megapascal, partial safety factor gamma MP equal to 1.25, ultimate stress F of E equal to 410 megapascal. Now we are going to find out the strength of plate in the joint. So what is the meaning of efficiency of joint? Strength of joint divided by the design strength of plate. So the strength of joint in the plate you can find out. So number of bolts in the weakest section is here 3 and the no stacker, that is here no bolt are in zigzag connections. Okay, now we are going to find out the net area at weak section. Here vertical you can see this diagram, 3 bolted are there, therefore net area equal to 180 minus 3 into 22 plus 0 is nothing but we have no stacking force, therefore this portion is 0. 20 is thickness of plate, therefore the area of net area of weakest section equal to 2208 mm square. The design strength of plate in the joint formula is TDN equal to 0.9 f of u an divided by gamma l. Substitute all the values. We will get 0.9410 into 2280 divided by 1.25. That strength of plate in the joint equal to 673.056 kilonewton. Strength of bolt, we are going to find out T two ways. One is design strength in shear, that is VDSP equal to VNSP divided by gamma MP. VNSP equal to f of u divided by square root of 3 NN AN plus NS ASP. Here no staggered bolt, therefore NS ASP equal to 0. Here NN equal to number of bolt is 6 and ANB equal to 245 area. Therefore find out VNSB equal to 339.482 kilonewton. Now we are going to design strength in shear formula to VNSP divided by gamma MP. Therefore that value equal to reduced to 271.586 kilonewton. So design strength in bearing VTPP equal to VNPP divided by gamma MP. Now we are going to find out KP value. These following conditions we are using: E divided by 3 T naught, P divided by 3 T naught minus 0.22, F of u divided by F of u. So you can solve all those things. 0.45 and everything. The least value equal to 0.4545. Therefore KP value is 0.4545. So VNPP equal to 2.5 kP TT into F of u. Substitute all the values. You can get single bolt value VNP equal to 186345 Newton. So design strength in bearing equal to 149076 Newton. Therefore design strength of joint 6 equal to 894.456 kilonewton. Among three values, the design strength in shear is the lesser value, 271.586 kilonewton. Therefore, the strength of joint equal to the strength of plate equal to 690 something, and the strength of bolt equal to 71894, whichever is lesser is 271. Among strength of bolt and strength of plate equal to 270, lesser value, which we consider the design 271.56 kilonewton. Therefore efficiency of the joint equal to strength of joint divided by strength of solid plate into 100. Therefore design strength of solid plate equal to Fy divided by gamma m naught into Aj. Therefore that value equal to 818.182 kilonewton. Therefore the efficiency of the latch joint equal to 33.19%. Thank you.